All right, guys, welcome to the last section of this module. And this section is going to concern something called a chemical hygiene plan. And we're going to abbreviate this because, again, we're very lazy and we don't like to write out all these words, and we're going to abbreviate it as a CHP. All right? So this whole module is going to, this whole portion of the module is going to concern a CHP document. And this thing is very important. It is a requirement. Now, it's not only a requirement of employees or employers, it's also a requirement of academic institutions. So that means anyone with a laboratory, doesn't matter how big the laboratory is, anyone with a laboratory should have what we call a chemical hygiene plan in place. So what we're going to do is that we're going to go through some of the things that make a very good chemical hygiene plan. And we're going to take a look at an example of one. And then at the end of this module, or this portion of the module, we are going to take a look at Cape Fear's chemical hygiene plan. So that way you get to see what our institution has created to operate under versus kind of the components that are required of any CHP and maybe another institution's CHP as well. So a lot of examples, a lot of comparison, just to kind of see where we stand in the whole CHP world. Now, just like before, I like to start off with an incident, right? I never really want to get away from these incidents because I think they're pretty important. It gives us some real-life teaching lessons in a way. So here's an incident. It says a scientist working in a laboratory was using hydrofluoric acid when he inadvertently put his finger in the solution. And it did not hurt immediately, but after a short time he began to experience severe pain. All right, so hydrofluoric acid has an abbreviation of HF. And hydrofluoric acid loves skin. But, immediately when he put his finger in, a little bit after, it didn't really hurt. So he didn't think anything of it, right? And that's typically what we do. If we expose ourselves to some type of chemical, if it doesn't hurt immediately, we just think it's going to be okay. But after some time, he began to experience severe pain. He washed off his finger and then went to the clinic. Okay, now here's a problem area, washed. So we have an acid spill, an acid exposure, and a lot of times wash means water. And water and acid makes things worse. There's a reaction that happens between them. So this could actually make the burn even nastier than what it was before. But he washed his finger off and he went to the clinic. So that was good news, right? He knew kind of where to go just to kind of let someone else take a check of it. The clinic physician learned that the scientist was using HF, but since the doctor didn't know that anyone was using this chemical on campus, he did not have the appropriate treatment for HF burns, which is a calcium gluconate gel. All right, so here's a problem, right? And this problem is communication. So how can we improve this communication on campus, right? We had HF on site. We had someone using HF in a laboratory. Apparently this was nothing new. And we had an incident with HF. They go to the doctor, they go to the clinic that was on campus, and they said, well, we have nothing to cure this. We have nothing to treat it. And the reason that we don't is because no one told us that you was using HF in a lab. So here's a communication barrier that needs to be prevented at all times, meaning that this laboratory should always be in constant contact with physicians' offices, doctors, anyone medical at the facility, and your employers should be as well. They probably will have maybe a medical doctor or a nurse on hand to let them know what is getting used in the lab. The scientist was sent to a city hospital. Well, that was more time, right? Where he finally received the appropriate treatment. His finger was severely burned, but at least he didn't lose it. This is something that's kind of common with HF burns. It will eat the skin so much that you can lose complete extremities, hands, feet, fingers, whatever the case is. So this could have been much worse, but he got lucky. The reason it could have been much worse is that this whole time that was wasted between visiting the on-site doctor and then going to a city hospital, the whole time in between those two cases could have allowed that acid to continue to eat away everything that it was exposed to. Now, keep in mind, what if this was more than just a finger in the hydrofluoric acid? What if this was an actual spill? What if this HF exploded, or HF was spilled all in the floor and someone was cleaning it up and didn't understand the dangers of it? Or what if it got in someone's face? What would happen then? So that's why communication is key. We always have to be in communication with the proper people on campus or the proper people at our employer's site. If not, then these problems can get much worse for us as an employee. All right, so some things to think about before we talk about chemical hygiene plans. Let's just kind of think about laboratory situations. So in a laboratory, maybe it's our laboratory, in a normal laboratory in town, what you would see is that you as an employee would be exposed to a variety of chemicals. I mean, our inventory is hundreds of chemicals on site. You could be exposed to many of those chemicals, right? Well, not only that, but these variety of chemicals, you're probably going to be exposed to them in a very small amount. So when we do work with them, we don't work with a lot of volume or a lot of mass. We use them in very small portions, and after that, we probably will never see them again. In addition to that, we're probably looking at very short times to actually use them. Meaning that we have a 3-hour lab period. You probably do a lab in 3 hours. After that 3-hour lab period, you might not ever see that chemical ever again. So we could be working with something hazardous, but we're working with it in very small amounts, and we're working in it in very brief times. Okay, so this is a normal lab space. And this is how most lab spaces are. No matter where I work, an environmental company, a pharmaceutical company, chemical processing company, this is typically what happens in the lab environment. Now you compare that to industry. And industry is basically a lab on crack. Okay? This is a full-blown laboratory, but the problem here is that we do not have a variety of chemicals. Maybe sometimes we just have a couple of chemicals that we use. So for instance, if I'm working for a company that produces sulfuric acid, well, there's probably only a handful of chemicals that I would be exposed to every day. That's it. I don't need the hundreds or the variety of chemicals that might show up in a working laboratory. I'm only going to be exposed to the ones that are actually needed and used on a daily basis. And sometimes this could just be a handful. That's it. Well, if I'm working on the processing or the manufacturing side, I'm looking at very large amounts of this stuff. Okay, so no more are we talking about milliliters of acid or milliliters of base or maybe milliliters of hydrofluoric acid. We're talking about vats. We're talking about gallons and tons, metal drums, huge amounts of volume and mass that we are working with. Then not only that, because it's done all the time, every day, all day, I'm going to be exposed to these chemicals for a very long amount of time. If I have an 8-hour work shift, I'm probably being exposed to that chemical for the entire 8 hours, give or take a little bit. And then not only that, but I do that Monday and Tuesday and Wednesday and Thursday and Friday. So this is long-term exposure here. So these two areas are completely different. The manufacturing industrial side is going to be completely different than the lab method or testing side. So each one of these will have their own idea or approaches to exposure. And that's what all this module is about, right? This whole module has been about chemical exposure. So a lab worker, their exposure concept is completely different than maybe the industrial processing, making side of the house. And OSHA knows this. OSHA has looked at these two scenarios and said, yes, we would like to limit your exposure to chemicals, but, we do understand there is a different need. Lab workers have a different need than industrial workers. Okay, so since I mentioned OSHA, let's talk about them in a little bit more detail before we go further. OSHA, under what we call the General Duty Clause, this is OSHA Act of 1970. This is kind of when OSHA first kind of came around, right? And under this clause, it states that employers should furnish to each employee a place of employment free from hazards that are likely to cause death or serious harm. That makes common sense, right? I mean, as an employer, I would want to make sure that the safety of my employees are at the utmost priority for me. If I have an incident in the laboratory, if I have an incident out on the manufacturing field, then the whole place is going to have to shut down. And as bad as you think about big companies maybe, you need to keep something in mind. If you think big companies do not have your priority first, sometimes that maybe could partially be true. But I also want you to think that these big companies, if there's an incident on site and you get hurt, well, the place is going to have to shut down depending on how bad the damage is, right? So if you get hurt and you get sent to a hospital over an incident that has happened, sometimes, depending on the manufacturer, the whole area has to be shut down, completely cleaned, checked to make sure that hazard is no longer there before they start back up. Or let's say that you did something accidentally and an explosion happened. The whole lab is going to have to be built back up from scratch. All of the downtime is going to cost money. So if you think that employers don't care about your safety and overall wellness, then maybe some employers out there are like that. But at the same time, you also have to understand that if they do not care about you and they allow incidents to happen all the time, every time they shut down, even if it's for one day, they are losing massive amounts of money. And if you think that employers are only in it for the money, then that's the last thing that they want done, right? They do not want you to have an incident. They want you to be safe. So at least this lab can continue to process and make samples, and so that they can sell their product. All right, so that's the OSHA Act of 1970. Furnish to each employee free from hazards that are likely to cause death or serious harm. All right, now, the issue I told you that is really industrial side. That's how all of this started out. And we've already discussed the difference between lab and industry. In addition to that, you also have to understand that OSHA does not cover students. You're not an employee. You do not get a paycheck. So therefore, things can happen to you and OSHA doesn't really care. I hate to say that, but that's just how this process works. They are in it for the worker. They are not in it for the student. You are not an employee. So finally in 1990, OSHA says, we understand finally there is a difference. We know there's a difference between the industrial side and then the laboratory side, based on some of those concepts we talked about in the very beginning of this video. And OSHA recognizes that there is a different approach. Yeah, you're going to have to be concerned with different things, and we know that now. So because of that, in 1990, OSHA basically implemented what we called the occupational exposures to hazardous chemicals in the laboratory. And this is abbreviated in what is commonly known as the lab standard. So we've seen this before, right? We've talked about the lab standard already. And now we're going to kind of take this lab standard and we're going to go another step into more detail about really what this consists of. One specific piece, at least. So, OSHA, 1990, went back, revisited, and said, yes, laboratories have their own things that they have to worry about that is different than manufacturing and processing. Because of that, we're going to implement what we're going to shorthand call the lab standard, which is basically exposures to hazardous chemicals in the laboratory. That's why this was different. Okay? Again, if I'm making sulfuric acid on the production side, I'm using large amounts. I'm using or being exposed to the same chemical over long periods of time. If I am testing that sulfuric acid that's made to make sure that it is sulfuric acid for a company, then I am getting exposed to a variety of different chemicals for very short amounts of time with very small volumes. Okay? But we still have to have a standard. We still have to kind of have rules and regulations that concerns the laboratory environment. So in the next video, we'll pick up from here and we'll continue on and we'll talk about this lab standard in more detail, which will eventually lead us to what we are calling the chemical hygiene plan.